Hello out there, welcome to this tutorial. It's on the cube. In this video we'll be looking at properties, net, surface area, volume and capacity of a cube. So we pick the first item, properties of a cube. A cube is a three-dimensional solid shape. It has 6 square faces. It has 6 faces. All the faces are square in shape. It has 8 vertices. It has 12 edges. It has 9 planes of symmetry. So we have 3 on the square faces and the remaining 6 on the edges. So we take a look at the diagram of a cube. So here is the edge, this is the face, and this is the vertex. So if you count the vertices, 1 2 3 4 up, 4 down, making 8 vertices. And for the edges, I have 4 here, 3 at the back, and so on. If you count also, you have 12 edges. So we go to the next item, the net of a cube. If a cube is dismantled and separated into its components, we will have 6 squares from the square faces. So this is shown in the diagram below. These are the 6 squares that will form the net of a cube. Meanwhile, the arrangement can be different, but what we know is there are 6 squares combined together if it is a solid cube. Then we go to the next item, surface area of a cube. Given the cube below with length or edges L units. So this is the edge or the length and it is L units. So the area of each square face is L squared, and since we have 6 faces, therefore the total surface area will be 6L squared, and that is all. The formula for calculating the total surface area, if it is open at one end, so the total surface area will be 5L squared. If it is open at both ends, it will be 4L squared to calculate the total surface area. So we go to the next item, volume and capacity of a cube. We still consider the diagram of the cube with length or edges L units. So the volume of a cube is, we know, base area multiplied by height. Since the base is L squared and the height is L, it will be L cube. So that is the relation for calculating the volume of a cube. Then the capacity of a cube, we always know if it is given in cubic centimeters. To calculate the capacity, we divide by 1000 and it will be in liters. But if the volume is in cubic meters, so we multiply by 1000, which will still give us in liters. And so far, these are the items we have highlighted. Now we go into solving problems related to surface area and volume. So problem 1, calculate the A, total surface area, B, volume of the cube below. So the edge of the cube is 8 centimeters. So in our solution, we have to calculate the total surface area, TSA, and we said it is 6L squared, and our L here is 8. Substituting L equal to 8, we have 6 times 8 squared. 8 squared is 64, so we have 6 times 64. 6 times 4, 24, 36, that will give us 384 squared centimeters, which represent the total surface area of the cube represented in problem 1. So we go to B part of the problem, the volume of the cube. So we said the volume is L cube and our L is 8, so we have it as 8 cube. 8 times 8 is 64, then 64 times 8. So 8 times 4 is 32. You write 2, carry 3. 8 times 6 is 48 plus 3, that's 51. So we have it as 512. So that will give us the volume in cubic centimeters. And that's the end of solution to problem 1. We go ahead to problem 2. For problem 2, the metallic cube has its edges 0.4 meters. Calculate its volume in A, cubic centimeters, B, cubic meters. So to find solution, we know the volume is L cube. So A, the volume in cubic centimeters, we are going to convert this 0.4 meters to centimeters by multiplying by 100, because 100 centimeters make 1 meter. So we have it as 40 cube, and that will be 40 times 40 times 40. If we concentrate on 4 times 4, 16, then times 4, it gives 64. So we then add 3 zeros, so that we now have 64,000 cubic centimeters. And the B part of the problem says volume in cubic meters. So what we just do is we just convert this to cubic meters by dividing by 100 3 times. Because if you have 10 centimeters and you want to convert it to meters, you divide by 100. If you have 10 squared centimeters and you are converting it to squared meters, we divide by 100 times 100. So now that we have it cubic centimeters, we are going to divide by 100 by 100 by 100, so that we have 64,000 divided by 100 times 100 times 100. So 2 zeros here, will cancel this 2 0. 1 0, we remove this 0. We now have 64 over 1000. That's going to be 3 decimal places, so it will be 0.064 cubic meters, which represent the volume of the metallic cube in cubic meters. And that's the end of solution to problem 2. We go to problem 3. For problem 3, a brick is in the form of a cube of edges 30 centimeters. Calculate the A, volume of the brick in cubic centimeters, B, mass of the brick in kilograms if its density is 2 grams per cubic centimeters. So in the solution to this problem, we are going to calculate the volume, and we know volume is V equal to L cube, and our L here is 30. So we have the volume to be 30 cube, and 30 cube is 30 times 30 times 30. So if you concentrate on 3 times 3 times 3, that will give us 27. We add 3 zeros, it will give us 27,000 cubic centimeters. Then to calculate the mass of the brick, we know mass is volume times density. So we have our volume to be 27,000 times 2, and 27 times 2 is 54. We add the 3 zeros, and it will give us 54,000 grams. And now that we are to convert it to kilograms, we divide by 1000, and that will give us 54 kilograms. And we go from here to problem 4. The internal dimensions of a cubic container are 90 centimeters. What is its capacity? So to calculate the capacity, we have to calculate the volume, and the volume is L cube, and our L is 90. We have 90 cube, which means 90 times 90 times 90. 9 times 9 is 81. 81 times 9 is 729. So we have 729,000 cubic centimeters. So to convert it to capacity now, we divide by 1000. That will be 729,000 divided by 1000 gives 729 liters. And that's the end of solution to problem 4. We go to problem 5. The capacity of a cubic tank is 8,000 liters. Calculate the length of the edges of the tank. So we know capacity is 8,000 liters. We can convert this to volume in meter cube or in cubic centimeters. So if you are converting it to cubic meters, we divide by 1000. That will give us 8 cubic meters. So we know that the volume is L cube and L cube is 8. So our L now will be cube root of 8, and cube root of 8 is 2, and the unit is meters. And that's the end of solution to problem 5, and this is the highest we can take in this tutorial. I hope you enjoyed it. Please like and share this video. Remember also to subscribe to our YouTube channel. Check the description section of this video on our YouTube channel to get links to other solid shapes with respect to their surface area and volume. Until we come your way again, goodbye.